Hi, I'm Bob. Today, let's do the exercises in Chapter 5, the GLS regression. We use the GLS estimators when the assumption of the homoscedasticity and non-correlation of the error terms fails. The OLS estimators are still unbiased as long as the explanatory variables are not correlated with the error terms. But they are not efficient. The GLS estimator is more efficient than the OLS estimator, meaning that it has smaller standard errors and larger t-statistics. We use a simulated dataset. We set the initial seed by using setSeed command so that you can rerun the program later and obtain the same results. We set the observation number 500. We draw 500 observations for x2 from a normal distribution with mean of 0 and standard deviation of 5. We generate the variables x3 and e the same way. Then we construct the error term u. Its variance only depends on x2. Finally, we construct the dependent variable y. We can take a look at the information of the variables using describe and summarize commands in Stata. To get the predicted variance of the error term, we run the OLS first, and then use the predicted command to obtain the residual, and then generate a variable that's equal to the squared residual. Then we can obtain the predicted variance of the error term by the nonlinear least squares. The first question in the 5.7 exercises asks us to use 3 methods to implement the second step of weighted estimation. First, use regress with the modifier analytic weights is equal to the inverse of the variance. Second, we manually implement this regression by generating the transformed variables. Don't forget the no constant option. The third method is to use regress with the sampling weights. It's equivalent to use the analytic weights with the robust standard errors option. I store the results of each regression using estimate store commands, and then use the estimate table commands to compare the estimates. The estimates are the same for all 3 methods. As far as the standard errors are concerned, the first 2 methods using the analytic weights or do it manually give the same standard errors. The standard errors are slightly smaller when we use the robust standard errors option. The first question is about the feasible GLS, and the second question, we assume that we already know the weight and then use the weighted least square. I don't find a big difference here between the weighted least square and the feasible GLS. In the third question, suppose that we incorrectly assume the variance of the error term. The estimates are very different from the OLS. I think the estimate is not correct because it is biased. Using the wrong weight may lead to correlation between the transformed explanatory variables and the transformed error term. Although the error terms in the transformed model are homoscedastic, as the post-estimate heteroscedasticity test shows. In question 4, we estimate 6 models. We are using the dependent variables in levels rather than in logs. We store the results for each regression model using the estimate store commands in Stata. First model is the OLS for the expenditures on prescribed jobs. The second model is the OLS with the robust standard errors option. The third and fourth models are about the expenditures on other medical services. Then we use the seemingly unrelated regression command in Stata for the system of 2 equations. The SUR regression command allows for the correlation of the error terms in the 2 equations. Finally, we use the bootstrap prefix to obtain the robust standard errors from the SUR regression. The estimates are a little bit different when we compare the SUR regression to the OLS. Notice that when we are using the estimates table command, the equations option allows us to match the equations from different models. In question 5, we declare the survey design first using survey set command. And use the survey describe command to take a look at the structure of the survey. The unweighted mean is similar to the weighted mean after considering the survey design, but the standard error is quite different because of failure to control for clustering. Then we run 3 regression models. We use the survey prefix in the first model and store the result. Then we use OLS in the second model. In the third model, we use the sampling weights and the cluster robust standard errors. We generate the unique identifier for each primary survey unit before running this regression. The regression coefficients are the same for the last 2 models. The standard errors are a little bit larger in the last model than those obtained when the survey prefix is used. For the last question, we compared results from the SUR regression for a system of 2 equations to the results from OLS for each equation separately.